All right. Hello, everyone. Is Chrome loading? Oh, cool, 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 cool. Um, Welcome. This is another study stream. My name's Aaron. I am a data scientist currently in government. So if you've never been to one of these, this is my twice weekly, Tuesday, Thursday study stream where I get on camera and I just like study something that might be helpful if I actually put the sound out to the correct output. It was going to my speakers and not my headset. So I do this twice weekly. I just get on camera and I just start studying something that I think is pretty interesting. Um, Last week, decided to start going over this Introduction to Statistical Learning textbook. This is free, so make sure you. I would highly recommend that you actually read this. It's really useful. It's really cool if you're doing data science or statistics. Yeah, sorry, I'm still kind of catching my breath. I went for a run, like normal, but it is. Excuse me. It is a bit warmer today than in the past, so it was a little tiring. So yeah, I'm still trying to catch my breath. Excuse me. Okay, so where we are, I thought Chrome would preserve the location, but we're in chapter 2, 2.2.1, it looks like. So we're just going to scroll down there, and then we're just going to get started. No need to mess around too much today, especially since we are starting a little late here. Let's shuffle stuff around. Actually, quite a bit late. If any of y'all know how to make Chrome preserve your spots when you're actually looking at a PDF, that would be awesome to know, because I was kind of hoping it would do that. Let's see, we're in chapter 2 already, 2.1.2. Let's zoom in a little. There we go. So hopefully today we'll get to at least start doing a lab. And actually, now that I mentioned that, let's just open terminal and see if we can get stuff going. Yeah, while I'm typing stuff out, how are y'all doing? I've got my eye on chat, and hopefully I can keep track of how things are. Having any progress studying things? Picking up anything new? I'm kind of curious. Okay, I've got Terminal and Visual Studio Code open, but we will get to those when we get to those. Okay, cool. I'm gonna mute myself for a second so I can cough. I don't know what it is. Every run, I get my throat gets like scratchy or something. I don't know if it's like pollen or whatever, but it's just like, oh, I'm still feeling it. So I'll probably cough again real soon. Okay, we're looking for 2.2.1. That was 2.1.2, 2.1.4. And we might make this a little bit of a short stream today, just so I can, well, we'll see. Might have some stuff to do later today. Two point two point one, measuring the quality of fit. And last thing I wrote was as model flexibility increases, training MSE will decrease, but test MSE may not. When training MSE is small, but test MSE is not, we are overfitting the training data. And that looks like... Yep, okay. We're right here. Um, that's more legible. Yeah, cool. That's better. All right, I will mute myself, and I'll come off mostly because as you can tell, my throat's getting scratchy again. I need a cough. But yeah, now's a good time to really focus on studying. I will check in like 45 minutes maybe. Yeah. All right. I'll see you soon. All right, sweet. So just finished the actual lecture material, so now it's time to do the lab. Yeah, I guess I guess I will just open Visual Studio Code now. Does that work? Yeah, kinda. I mean, it works when I don't have OBS open. I really want that second monitor here. Yeah, okay, cool. Okay, so this is going to be the intent. Let's just write in here 2.3 lab intro to R. But in this case, we're doing Python. To R Python. And then we want to import SciPy. Import SciPy stats. I'll be honest, I've never used SciPy in this way. I usually use it as a backend, like a dependency for things like pandas and numpy. So this is definitely going to be different. And I already messed up, so I'm going to save this, close this out. Poetry shell. Now code dot. And hopefully we can see the kernel in here. I guess that worked. I don't really like how this kernel is named. Oh well. Okay, basic commands. Let's actually split this cell. Split this again. Numpy and let's say SciPy. Pandas and SciPy. Specifically the stats module from SciPy. So import pandas as PD from sci import as stats. Okay. Okay, so R uses functions to perform operations. To run a function called function name, we type function name input1, input2, where the inputs or arguments tell R how to function, or how to run the function. A function can have any number of inputs. We use the function C for concatenate. Any numbers inside the parentheses are joined together. The following command instructs R to join the numbers together. Join the numbers 1, 3, 2, and 5 together, and to save them as a vector named x. When we type x, it gives us back the vector. So in this case, what we want to do is I want to change this cell to Markdown. Python can use functions to perform operations. To run a function, man, I think maybe this this R instruction's a little bit too rosy, I guess, because it kind of assumes I already know what all the functions are called. You type func name with its inputs in parentheses for, let's see, a function can have any number of inputs and sorry, I don't know if you can hear that. I'm actually watching a friend's stream. Just know that they've got support. But I am kind of lurking. And it was nice to hear him talk. It's a little bit of background noise when I was reading. Let's see. So a function can have any number of inputs, and it is best practice to load the function's documentation to see specifics on how it operates. Let's see. As an example, we will use Numpy to create an array from 4 integers. If you want to see specific documentation on this function, you can check out the Numpy array documentation manual here. Hitting the up arrow multiple times. I see. So they also wrote this in a console as opposed to in a Jupyter notebook. And I'm going to prefer, in order to do what they're doing, I have to write in IPython, and I don't want to do that because it would be extremely difficult to extract the notebook after, or extract the code after and put it in a notebook. That's just easier to read. So I'm just jumping straight away into a notebook file. I'm kind of surprised that they weren't doing that, I guess because they're using RStudio. Okay, so let's create another array. And perform some operations on them. also do print. We'll use a built-in Python function to tell us the info about the arrays. And I'm going to pop in a, okay, cool. So I'm going to use the length command, len command, give us a count of elements inside the array. Even though we already specified it above, it, good test to see if it's working. And then similar with the vector y. We can tell R to add two sets of numbers together. It will then add the first number from X to the first number of Y, and so on. However, X and Y should be the same length. We can check their length using the length function. The ls function allows us to look at the list of all the objects, such as datum functions that we have saved before so far, and the rm function can be used to delete any that we don't want. I don't know if that actually exists in Python. I have literally never used anything like this in Jupyter or Python or IPython, and let's actually see. Python ls. Is there a quick way to get the R equivalent of ls? You're probably looking for dir. Without arguments, it returns the list of names in the current scope. With an argument, attempt to return a list of valid attributes for the object. This may not be entirely obvious at first, but when you're at the global scope, as you usually are at the command line interpreter, the current local scope is the global scope. Okay, so interesting. So we can write that down. Insert markdown cell above. The dir function allows us to look at a list of all objects such as data and functions that are in our current scope. Basically, things we have saved so far. Python equivalent to RM. Here we go. Thanks, Stack Overflow. Garbage collector. The del function can remove pointers to specific objects to free up memory. I believe that's a summary of what that was. So if we... Oh, that's not what I want to do. Whoops. Undo. I think I was trying to use a function. That's interesting. Huh. What happens if I run this? Well, I kind of did it. This is so last time I wrote like this function, trying to exclude the things that are actually defined in like global scope, because if we do this, like that's too many things, and the only things we really care about turns out are actually the x and y variables at the very end. These other things are all from global scope, and they're just like especially with the dunders, the double underscores, like those are not things that like we explicitly asked for or created. Those are just things that are running. So it's kind of interesting. Like, how can I? Oh wow, interesting. It's even like saving all the cell running results. Okay. Well, let's see if we del x y, and then we can do dir. And look, they're not there anymore. I'm not going to try. I'm going to write this out because of how dir returns all things in local scope. I will not try to remove all objects at once. And insert another markdown above. The matrix function as referenced in, let's see, numpy dot mat function. Let's put parentheses in there. Can be used to create a matrix of numbers. Let's see what the documentation says. Actually, so Jupyter print function documentation. So will this work if we try to do help numpy dot, let's do np dot array. There we go. Okay. And then that means that we can do similar with help dir. Help del. What did I do wrong? Interesting. Can't get the help documentation for Python del. Oops. It's kind of interesting. The syntax for del like since it doesn't have parentheses around the arguments, is a little odd to me. Because normally with Python, like at least when I've used it, you need that thing there. Um, I don't know if this really answers my question. Insert markdown above, C. Okay, so now we can do help np.mat. I kind of wonder numpy mat versus array. That's interesting. So numpy matrices apparently can only be two-dimensional, but numpy arrays can be n-dimensional. So I think that's kind of interesting because like when I was taking math classes, like matrices did not have a limit on the number of dimensions. So it actually kind of seems like just sticking with numpy arrays is better. Let me actually write that down. Change cell to markdown. According to Stack Overflow discussion. Put the link. NumPy arrays are n-dimensional, but matrices are two-dimensional. May be better to just stick with NumPy. Yeah, it does say that matrix multiplication becomes really easy if you stay with NumPy with the matrices. But and then newer versions of Python have things included, but otherwise you have to use like looks like np.dot. Yeah, interesting. It's just the functions are a little bit different. So if we wanted to keep this as an array, the example one, so we have this would be 1, 2, 3, 4. So I think it's like you make a list, you make, and then cool. All right, so sometimes it can be useful to specify the names of the arguments passed in, since otherwise R will assume that the function arguments are passed into the function in the same order that is given in the function's help file. As this example illustrates, by default, R creates matrices by successfully filling in columns. Alternatively, the by row equals true option can be used to populate the matrix in order of the rows. Okay. This actually, I mean, this makes sense to me. In Python, like, if you don't specify, like, I've written functions where, like, the arguments are put out of order, but because you actually put, like, this equals this part of the argument, this number equals this argument, then like the order didn't seem to matter as much, but it would just drive me crazy if they didn't line up. So it's interesting that R has the same functionality. Okay, so we've got so x equals, and then print x. All right, so that is working. Oh, it's not working. Let me see. So they wrote the matrix X should be 1, 2, 3, 4, and by default it fills in columns. So what that did was it did 1, 2, 3, 4. But the default for NumPy, well, actually, because I wrote it in this way, it's already made this like by row equals true. So if I actually wanted it to follow the other convention, it'd be x equals np.array list, and a list, so it'd be 1, 3, and then 2, 4, and then print x 1, 3, 2, 4. Yeah. So let's see. I want to convert this to Markdown. And then because of how they did things, it's not saved. It's just printed to the screen, but I just saved it. So the np.square-root function returns the square root of each element of a vector or matrix. So let's print this so it looks a little bit neater. Yep. And then add a cell above, insert markdown cell above. The np.power function raises each element of x to a specified power. So let's say we print okay. The rnorm function generates a vector of random normal variables with first argument n, the sample size. Each time we call this function, we will get a different answer. Here we create two correlated sets of numbers, x and y, and use the core function to compute the correlation between them. So we want to generate a random normal vector according to R with a mean of 50, a standard deviation of 0.1, and we want 50 elements in it. So this is the part where I think we start using SciPy. Oh, look, rv equals norm. All right, so I'm looking at the documentation. How can we just make... All right, random variables, continuous random variables, discrete random variables. Over 80 continuous random variables and 10 discrete random variables have been implemented using these classes. All of the statistics functions can be located in the subpackage scipy.stats. Fairly complete listing of these functions can be obtained using info.stats. The list of the random variables can also be obtained from the docstring for the stats subpackage. In the discussion below, we will focus on continuous random variables. Nearly everything also applies to discrete variables, but we point out some differences at this link. Okay, so we have imported scipy stats. So what we want to do is use norm. So let's say help stats.norm. Normal continuous random variable. That's the probability density function. Okay, so we want to actually make a vector of this. To generate a sequence of random variables, use the size keyword argument. So this is if we use NumPy. But what happens if we use norm? So it'd be stats.norm 50. Oh, .rvs size equals let us look at the actual documentation. That's not really what I wanted. Normal distribution. From scipy.stats import norm. Why don't you just tell me what the... Okay, so we want a location of 50, a scale of 0.1, and a size of 50. So we've got size. We want location equals 50. The scale equals 0.1, and then size equals 50. Let's call this x1. I don't really like how they kept reusing the same variables. So let's print x1 and then print x1.shape. I think I messed up. Y is the thing that's supposed to be location around 50, but this one should be location around 0. Okay, cool. All right, so that's stats.norms, norm.rvs. Okay, so x1 is going to be that. And then we have y equals... let's actually add some this would be with using NumPy. Add a markdown cell above. Oh, that's not what I wanted. Insert cell above using NumPy functions. NP, so it'd be x, whoops, 1x NP and 1 NP, and then let's actually move this up here. So y1 NP, P. I'm pretty sure I'll rename these later because I kind of hate this name. I just want to make sure that they're distinguished and I don't keep overwriting the same variables. So we have this, had something in here, insert markdown cell above, double heading level 2 using SciPy stats functions. So x1 SciPy just copy paste this every time there's a 1. And then y1 equals x1 p SciPy plus, and then the same nomenclature, stats.norm.rvs look equals 50, scale equals 0.1, size equals 50, print y1 SciPy, print y1 SciPy dot shape. All right, cool. And then we want to see the correlation. Let's see. SciPy correlation. Correlate. Signal processing. I don't think that's entirely what I want. Well, I think we just want a Pearson correlation. Let's see. R core. Oops. Like what type of... I'm assuming that this is just Pearson. Core function. What is the default method? I am really assuming that the default method is Pearson. Yep. Okay. So for SciPy.stats, what we can do is, actually we can, insert cell, code cell below. We want to find the correlation. So here we can use Numpy correlation. So it'd be np.corcof x1, x1 np y1 np And if we wanted to do the same with SciPy, it would be stats.pearson r x 1 SciPy y 1 SciPy. I still had that on my clipboard. Okay, cool. So this gives us the correlation and then also the p-value. Yeah. Yeah, it's right there. Cool. So that works okay. And unfortunately, because these are random numbers, they're going to change every single time because I did not set a seed. And oh, look, they talk about setting a seed. Oh, wow. Has it been it's been longer than 45 minutes. I just got really wow, an hour and 13. Sorry, I just got really into like, oh, cool, we're finally like in a Jupyter notebook and coding. So sorry to miss that. And I think given I'll take a quick break and answer some text messages. And I'm just going to mute myself for a second. And I was muted. Okay, so sorry, that was a super quick break. I was looking at my phone, and I'm actually trying to settle some logistics, like seeing a friend of mine. Um, so I need to actually like look at my phone. Um, and because of that, and because of the content of the streams, right now, like all I'm doing is basically just going through this tutorial, which I don't think is like the most exciting, but it is resulting in like at least I'm writing some code, and hopefully it'll be helpful. But there's not really any sort of like problem solving. It's like checking documentation, running a cell, et cetera, et cetera. So I might do this later, like off stream. Maybe I'll just hop on stream just to have something up, I guess. But I know that this is not like the most exciting stuff. Yeah, so I think I'm gonna call it for now, and then I will check in later. At the very least, you'll probably see me Thursday during a normal study stream session. So yeah, with that, I am going to start the exits, and I am really looking forward to diving more into these labs. It's really exciting to actually like start coding. And like even at work, honestly, like not a whole lot of code, and it kind of sucks. So it's good to actually do these things, and converting things over from R. Like it looks so nice to see the R syntax is like so clean. But and trying to translate it into like different Python functions is like, well, this is annoying. But hopefully this kind of stuff will be helpful to people in the future. And I still need to get in contact with the authors of the book and stuff. But yeah, anyway, I'm looking forward to get to seeing you all later, and I hope otherwise you have like a great rest of the day, rest of the evening. I don't know. Yeah. My name is Aaron again. And if you have any questions, feel free to contact me. Everything should. I mean, you found my YouTube profile. All right. I'll see you later. Bye.